Hi guys, this is the South County Math Tutor, and I am here to talk about complex numbers by request. Okay, so first things first, I want you to please ignore the noise. I am in the motherland. Yes, I am. I am in Nigeria, and therefore I'm outside, and there's a lot of noise. So if you hear that, just ignore it. I'm here, so listen to me. Okay, so we're going to talk about complex numbers, the motivation for complex numbers, and specifically how to multiply and divide complex numbers. Okay, so before we begin, let's go ahead and talk about the motivation for complex numbers. Okay, if you had this square root of 4, we know what that is. That's 2. We have square root of 1. We know that what that is. That's 1. But whenever we had square root of negative numbers, so let's say square root of negative 1, we usually said that that had no solution. That actually, that answer is partially true. It has no solution in only the real number system, but we have defined a system that actually you can use to get a solution for the square root of a negative number. And that is what we call I, or imaginary number. Okay, so imaginary numbers are numbers that we created so that we can have square root of negative numbers. So from now on, if you have something like the square root of a negative 4, well, that is 2 and I. So the I is used for to go ahead and kind of define the negative inside the radical. All right, so let's talk about powers of I. Okay, so I'm going to tell you why. That way you can, instead of memorizing it, you could actually derive it if you need to. So, well, I is I, and I is the same thing as the square root of negative 1. I squared is negative 1. Okay, so let me derive that. So remember, I squared is I times I, which is like saying the square root of negative 1 times the square root of negative 1. Okay, and remember, when you multiply two square roots, all that does is it just takes away the radical. So this is negative 1. So that's kind of how you derive it. So I squared is negative 1. Okay, I cubed is negative I. Okay, so I cubed, you can think about it as I times I squared. Well, we already know that I squared is negative 1, so I times I squared is negative I, and then I to the 4th power is 1. Okay, so I want you to prove to yourself that I to the 4th power is indeed negative 1. Okay, so we don't like powers of I, so that's why we go ahead and do this. So if you have I squared, that's negative 1, I cubed, negative I to the 4th, 1. Okay, so if you had a question that wants you to simplify, okay, so simplify, and let's say it has I to the 20th. Well, I to the 20th is I to the 4th 5 times, correct? Okay, so it's I to the 4th 5 times. Well, we know that I to the 4th is 1, so I to the 4th to the 5th power is just 1. Okay, so if there's a number that is divisible by 4, then the answer is 1. Well, let's say if it's a number divisible by 4, but it has a remainder. So I to the 101. 101 to the 101. Okay. Well, I to the 101, well, we know that I to the 100 is divisible by 4 times I. So this is 1 times I, which is 1I, or the same thing as I. Okay, so you can essentially use that definition and use the powers of I to be able to do numbers where you have I to any power, I to the 1 million, I to the 105, I to the 27. So you can do that. Okay, so now we've talked about imaginary numbers, how imaginary numbers relate to real numbers. Okay, so that's that. That's what I want to talk about with that. Now let's go ahead and talk about complex numbers. Complex numbers. numbers, this is kind of a mathematical definition, come in the form a plus bi. Okay, where a is the real and bi is the imaginary side. Okay, all numbers are technically considered complex numbers because, for example, a real number like 5, example 1, a real number like 5 could be defined as a complex number, but it just, the imaginary side is 0. So this is like the same thing as saying 5 plus 0i. Well, the imaginary part is 0, so it's strictly real. Okay, but you would also have things like 5 plus 2i, where 5 is the real component and 2i is the imaginary component of that number. Okay, so, well, how about simplifying? Let's go ahead and move quickly on to simplify the complex number. All right, simplify the complex number. Well, adding complex numbers, let's see, 2i plus 3 minus 4i. Okay, adding complex numbers are just like combining like terms. You put the reals together, you put the imaginaries together. Okay, so first things first, let's go ahead and put the reals together. The only real we have is 3, so 3, 3. Okay, now for the imaginary number, you have 2i minus 4i. Okay, 2 minus 4, that's a negative 2i. Okay, so it's just like combining like terms. I'm not going to do too many examples of these because if you can combine like terms, you can add and subtract complex numbers. Okay, so let's say you had 6 minus 2i plus 4 plus 2i, okay, minus 7 minus 3i. Okay, so on the first one, there's nothing in front of this parenthesis, so I can drop it. 6 minus 2i. Plus doesn't change the parentheses, so I can also drop that. So plus 4 plus 2i. But notice how you have a negative in front of a parenthesis. You have to use the distributive property, so distribute the negative. So this is negative 7. Negative times a negative 3i is a positive 3i. And then once you do that, you can go ahead and combine like terms. Okay, so reals go with reals. So 6 plus 4 minus 7. 6 plus 4 is 10, minus 7 is 3. All right, now we do the imaginary. Negative 2i plus 2i, that's a 0i, plus a 3i, so that's plus 3i. So your final answer is 3 plus 3i. Okay, again, I'm not going to do that many examples because I believe that if you have the skills to combine like terms, which by this time in your algebra, you should be able to have those skills, you can do this on your own. Now, the next thing that I want to do, I kind of want to focus this video on is multiplying and dividing complex numbers. Okay, so let's go ahead and do that. Number 3, we want to multiply. Okay, so two complex numbers. 5 minus 2i times 2 plus 3i. Okay, notice this is like a binomial times a binomial. That's a skill that you've done. That's something that you should know as well. What we usually use is FOIL, and you can use FOIL on this, okay? I use my arrow method. You use FOIL, no big deal. Some people use box method. Box method also works. Okay, so 5 times 2 is 10. 5 times a positive 3i, okay? So you just do this like it's just an expression. 5 times 3i is positive 15i. Multiply the coefficient and add the exponents. Okay, negative 2i times 2 is negative 4i. Negative 2i times positive 3i, just like you would do would be negative 6. I times I is I squared. Okay, step 2, combine like terms. These two i's in the middle are like terms. Notice I'm not going to combine them with I squared because I and I squared are not the same. So you have 10. 15 minus 4 is positive 11i. Okay, minus 6i squared. Now remember, we don't like powers of I. We don't want our i's to have exponents. So we want to figure out what I squared is. Well, if you go back to my definition, I squared is negative 1. So you're going to have to substitute I squared for negative 1 because, again, we don't like powers of I. So instead of I squared, I'm going to put negative 1. Okay, so this is negative 6 times negative 1, which will give you positive 6. Okay, bring everything else down. So this is 10 plus 11i. And then combine like terms again. So now this becomes real. So this is 16 plus 11i. Okay, so quick review. How do you multiply imaginary complex numbers? Step 1, FOIL. Okay, step 1, FOIL. Step 2, combine like terms. Combine like terms. I'm going to write LT. Okay, step 3, you want to simplify powers of I. Powers of I. And then you combine like terms again. Combine like terms again. Okay, if you follow that step, if you follow that process, you will always be able to multiply complex numbers. Okay, well, what if you have a strictly real number? Okay, so let's say strictly real, 10 times a complex number, 3i. Okay, distributive property. So this is 20, 10 times 3i plus 30i, and that's it. There's no powers of I. That is your final answer. What if you have a strictly imaginary number, 5i times 2 plus 3i? Okay, distribute. So 5i times 2 is 10i. 5i times 3i is 15i squared. Again, notice you have powers of I. I squared is negative 1, so you're going to substitute I squared with negative 1. Okay, once you substitute, you simplify. So this is 10i minus 15. We like to write the real first. It doesn't really matter. But so this is negative 15 plus 10i. Voila, no big deal. Okay, now how do we divide complex numbers? So let's say we have simplified. And you have constant 6 over 2 plus 3i. Okay. Now, when they talk about simplifying complex numbers, what they're actually saying is if you have an imaginary number in the bottom, we don't like that. Okay, so you do not like to have complex numbers on the bottom of a fraction. So if you do, you need to do something to get rid of it. Okay, so to be able to do this, first I want to show you something. Alright, so let's see, let's say you have 2 plus 3i times 2 minus 3i. Let's see what happens. Let's FOIL this. So 2 times 2 is 4. 2 times negative 3 is negative 6i. 3i times 2 is positive 6i. 3i times a negative 3i is a negative 9i squared. Check this out. Negative 6i plus 6i becomes 0. That cancels out. So this is 4 minus 9i squared. 9i squared, well, I squared is negative 1. So that negative 9i squared now becomes positive 9. 4 plus 9 is 13. Notice what happens. We went from a problem that is complex, a complex number problem, and we got a real number. Well, it turns out that always works. Notice, let me show you what's very important about this. Notice how this is the exact same numbers. Okay, so we have the exact same numbers, but we have different signs. One is a positive, one is a negative in the middle. Okay, so those are called conjugates. Okay, this baby is called a conjugate. They are called conjugates. Okay, so that's how you want to get rid of bottoms that are complex and make them real. Okay, so to get rid of a complex conjugate, to get rid of a complex denominator, what you want to do is multiply by the complex conjugate. And the complex conjugate so a complex conjugate takes the exact same numbers, the exact same number for real and for imaginary, and it changes the sign of the imaginary. Okay? So it's the idea of the difference of 2 squared. Remember, if you had a plus b times a minus b, then it's going to be a squared minus b squared because the middle terms cancel out. Okay, so just to be consistent, we usually just change the sign, keep all the numbers, everything the same, but we usually just change the sign of. Alrighty then. So here the complex conjugate is 2 minus 3i. So you're going to multiply the top and the bottom by 2 minus 3i. Okay, so 2 minus 3i. Why do we multiply the top and the bottom? Because we need this to continue to be a true statement. Remember, we're using the fact that any number times 1 is itself. Any number times 1 is itself. Okay, so you're multiplying by what we call a form of 1 because, okay, so multiplication identity, 5 over 5 is 1. Anything divided by itself is 1. Okay, so 2 minus 3i over 2 minus 3i equals 1. So we're multiplying by a form of 1. So yes, you have to multiply top and bottom by that number. Okay, I like to put parentheses just to be precise, just so I don't make mistakes. Okay, so that I can recognize what's going on. So as you can see on the bottom, you have FOIL. On the top, you have distributive property. So 6 times 2 is 12. 6 times a negative 3i is negative 18i. Okay, and then on the bottom, 2 times 2 is 4. You're FOILing. 2 times a negative 3i is negative 6i. 3i times 2 is positive 6i. 3i times a negative 3i is negative 9i squared. Okay, let's go ahead and simplify the bottom. These two are the same, they cancel out. I squared is the same as negative 1. I squared is negative 1. Okay, keep the top. Okay, and divided by 4 minus 9 times a negative 1, which becomes 4 plus 9, which becomes, I'm going to write all my steps, 4 plus 9, which becomes 13 on the bottom, and on the top you still have 12 minus 18i. So if you use that steps, if you use this process, you should be able to get this right. Okay, so 1 multiply top plus bottom by the bottoms, B for bottoms, conjugate. Okay, and then 2 simplify. Okay, can either FOIL top or bottom, or you distribute top, FOIL bottom, depending on what the problem is. Okay. Okay, so I'm going to do one more example of dividing complex numbers. Okay, so let's say that I have, where am I here? I think I'm on number, let's call this number 5. Okay, so number 5. Let's say I had 2 plus I divided by 3 plus 5i. Step 1, multiply by the conjugate of the bottom. Okay, so the conjugate of the bottom would be 3 minus 5i. Okay, so 3 minus 5i. 3 minus 5i. Alright, 3 minus 5i. On the top and the bottom, because that is the form of 1. Okay, Notice I have binomial times binomial on top and bottom. Therefore, you will be FOILing or box method or whatever method you like. Just remember you have binomial times binomial. So 2 times 3 is 6. 2 times a negative 5 is negative 10i. I times 3 is 3i, positive 3i. I times a negative 5i is negative 5i squared. Alright, on the bottom, you can do that. 3 times 3 is 9. 3 times a negative 5i is negative 15i. Okay, 5i times 3 is positive 15i. Okay, and 5i times negative 5i is negative 25i squared. Okie dokie, simplify. Okay, on the top, notice i's go together. Okay, combine like terms, so simplify in the top. So this is 6, negative 10 plus 3 i's is negative 7i. And negative 5i squared. Well, I squared is negative 1, so this is negative 5 times negative 1, which is positive 5. Okay, I skipped a step right there. Okay, so again, I skipped a step right there. Okay, because negative 5, I squared is negative 1, so I substituted negative 1 for I squared. I'm not going to skip that step in the bottom. Okay, so negative 15i plus, that should have been 15. So negative 15i plus 15i are the same, so those are 0, that crosses out. And now I have 9 minus 25i squared. Okay, so let me show that substitution. 9 minus 25, I'm going to substitute. Substitute means replace. Instead of I squared, I replace that with negative 1 because by definition, I squared is negative 1. Okay, and then on the top, I'm just going to continue to simplify. So 6 plus 5 are like terms. Those are real, so they are like terms. So 6 plus 5 is 11 minus 7i. Okay, and then I'm going to finish up my bottom. So this is 11 minus 7i over 9. 25 negative times negative 1 is positive 25. Okay, combine the bottom. So bottom you have 34 over 11 minus 7i. Okay, so now what you learned what complex numbers are, you learned how they relate to real numbers, you also learned how they relate to imaginary numbers and what imaginary numbers are. We multiplied complex numbers, we divided complex numbers, and we did quick examples of adding and subtracting complex numbers. I hope that helps. Email me if that did not help you. I think that now you can go ahead and complete the complex number worksheet, and later I'm going to do a few more examples of manipulating complex numbers. Thank you.